everyone, have you ever experienced this? The foam looks quiet while resting in the warehouse, yet suddenly a fire breaks out. Why does freshly produced foam become the most dangerous time bomb after it comes off the line? Today, we're talking about on-site management of flexible PU foam. This is the last line of defense in preventing factory fires, and every producer should understand it. Part 1. Monitoring the invisible high-temperature peak. Foam coming off the production line does not mean the reaction has stopped. On the contrary, large foam blocks typically reach their internal temperature peak 2 to 4 hours after demolding. To enter the cooling phase, it usually takes at least 3 to 4 hours. This is why the foam surface may feel cool, while the core temperature has already reached 200 degrees Celsius, the point of self-ignition. Therefore, during the first 12 hours after demolding, dedicated personnel must be assigned for inspection. During high-risk periods, measure the temperature every 15 minutes. The temperature probe must be inserted deep into the core center of the foam block. Remember this clearly, 160 degrees Celsius is the warning threshold. Once the temperature exceeds 117 degrees Celsius, spontaneous combustion can occur at any time. Part 2. The time difference principle for stacking management. To ensure proper heat dissipation, stacking must strictly follow the time difference principle. Never stack foam simply to save space. Peak phase stacking is absolutely prohibited. Foam blocks must be arranged in a single layer, with a minimum ventilation gap of 100 mm. Curing phase, after the temperature peak, only when the temperature starts to decline is stacking allowed, and the stack height must not exceed 3 layers. Part 3. Hardcore safety configuration of the storage area. A qualified curing area must meet strict hardware safety requirements. This is a mandatory daily inspection checklist for supervisors. Monitoring tools, accurate long probe thermometers or temperature sensors are required. If conditions allow, infrared thermal imaging cameras are highly recommended. Firefighting facilities, fire hydrants and extinguishers must be adequately installed and within their valid service life. Ventilation and environment. Good ventilation is mandatory, with high-power exhaust fans installed. In summer, strict precautions must be taken to prevent direct sunlight exposure. Emergency response. Emergency lighting must be installed. All operators must receive fire safety training and be familiar with evacuation and emergency handling procedures. Part 4. Emergency response survival rules. If you detect smoke or a burning smell from the foam, remember these 3 absolute rules. Do not move the foam casually. Movement introduces fresh air, which can instantly turn a smoldering fire into a flash ignition. Do not open doors or windows widely. A sudden influx of oxygen will rapidly intensify the fire. Do not cut blindly. Unless it is preventive heat dissipation, once smoke appears, cutting will only feed oxygen to the fire. Correct response. Stay calm, control localized ventilation, immediately apply continuous water spraying to the core area for forced cooling, and notify the fire department at once. Part 5. Preventive heat dissipation measures. If the temperature is detected to be abnormally high but no smoke is present, proactive preventive cutting can be performed. Cut large foam blocks horizontally into sheets no thicker than 200 mm. By increasing the heat dissipation area, the temperature can be forcibly reduced. During cutting, ensure the blade is sharp and minimize compression and deformation of the foam. Foam safety starts with formulation and is secured through management. After all these preventive measures, is there a way to fundamentally eliminate the risk of foam self-ignition? In the next episode, we'll share the most hardcore technical solutions, introducing 3 industry-leading foaming technologies currently in use. Follow us to make production more efficient and safer. See you in the next episode.